Today we're gonna look at the precise definition of limit together. This chapter is what most people find a bit confusing because you have delta, a, epsilon, all these variables, and you also have absolute value equations that you need to solve. But don't worry, in today's video, I'm gonna try to break down these concepts and show you what each of those equations mean exactly. So here we have the precise definition of a limit from a textbook. You can quickly pause and take a look. Okay, so here we want to first focus on this equation. What does this equation mean in English? So this equation here means the distance between x and a is greater than 0 but smaller than delta. Let me give a more specific example here. So a and delta are just variables. Let's say we have a is equal to 5 and delta is equal to 2. So then we would have 0 is smaller than x minus 5, then smaller than 2. What does that mean on a graph? It means if we have an axis and here is 5, and on the right side we would have 5 plus 2, which is 7. On the left side we would have 5 minus 2, which is 3. This equation means my x value need to be between 3 and 7. So it could be any number in between them. So that means the distance between x and a is smaller than delta. Your a and delta can be other numbers as well, but the concept remains the same. Okay, then what if we use a and delta in the x-axis to give it a more general solution? Then we would have your a is here, this is a plus delta, this is a minus delta, and your x value is in between a minus delta and a plus delta. So this would be your x value. So your x could be any number in between them. Just like in the example, your x can be any number between 3 and 7. So the same concept holds for this equation as well. Let's try to write it in the x's. You can see here instead of x, we have f of x, which is your y value. In here, we can use y or f of x. So in this axis, we have, in the middle, we have L, and the distance between fx and L is smaller than epsilon. Then this would be L plus epsilon. This would be L minus epsilon. And then your f of x value need to be in between them. Because only if your f of x is in between them, then this equation, you can satisfy this equation here. Let's look at the graph on the right side. So we can write the limit at x approaching 3 in the following way. I think this we're pretty familiar with already. Limit of x approaches 3, f of x is going to equal to 5. Okay, so by definition, if you look at this equation here, we already know your a is equal to 3, which is the number x is approaching to, and your L is going to be equal to 5, which is our limit. So what does this part mean? It means for every number epsilon is greater than 0, there is a number delta that satisfies the following condition, which means your epsilon could be a very small number. It could be 0.1, it could be 0.01, it could be 2, 3, or 100. It could be any number. I can always find a delta. So that the following conditions satisfy. So the following condition is if this equation means my x is in between this orange line here. Let's look at the graph. This is my x value, so the distance between x and 3 is smaller than delta, means my x falls into this orange line. Then I can always find a range, find this delta range for x, so that my y value, the distance between my y value and the limit is smaller than epsilon. So if I can find this x range value, then my y value can always satisfy. It falls into the limit plus or minus epsilon. So my delta can always be found. So in this way, it might still be a little abstract. Let's look at a more concrete example. In the graph here, it says use the given graph of f to find a number delta such that if x minus 1, the absolute value of that, smaller than delta, then f of x minus 1, the absolute value of that, smaller than 0.2. Okay, so this question wants us to calculate delta. Delta equals to what? So that if this is true, then this is true. So this part here is the condition. And this part here is the result. Okay, let's look at the result first. It means f of x minus 1 is smaller than 0.2. Let's write that in English. Then what could your f of x be? We can already know my f of x need to be greater than 0.8 and smaller than 1.2, which is this orange range right here. Anything in between those is okay, but it cannot go beyond this orange range here. Okay, so now we know our result. What condition do we have to have so that the result is satisfied? Let's look at the one on the left. So this condition is the distance between x and 1 is smaller than delta. Okay, so if we look at the graph, at y equals 1.2, we have x is equal to 0.7, and at y is equal to 0.8, we have x is equal to 1.1. In here, we have two delta, right? We have delta 1 is equal to the distance on the right side, which is 0.1. On the left side, we have a larger delta, which is 1 minus 0.7. That gives us 0.3. So which one should we choose? So the answer here is we always want to choose the smaller delta. So let me show you why we want to choose the smaller delta. Okay, so if we choose our delta to be 0.1, then we have our x will be between 0.9 and 1.1. Let's take a look on the graph. So if my x is between 0.9 which is somewhere here, and 1.1. Then we look at where the y value lands. So we go up here, and we go up here, and then go up here. So this will be our y value. We can see this range is within the orange range, which satisfy our condition. Let's take a look at if we use a larger delta, what will happen. Then our x will be in between 0.7 and 1.4. So this is when we use delta 1. This is when we use delta 2. Sorry, 1.3. So if we use delta 2, the x value will be between 0.7 and 1.3. Let's take a look. 0.7 is here. We go up. It'll be 1.2. And then 1.3, it will be somewhere here. Intersect with the function and then goes to the left. Okay, so if my x is within this range, then my y will be within this black line range. You see here, this is greater than the orange range, which means this condition cannot be satisfied when we use a larger delta. So therefore, we do not use the larger delta, we keep the smaller delta. So our delta could be 0.1. So just want to add one last thing here. The solution for this question is not unique. So as long as my delta is smaller than or equal to 0.1, this result can always be true. And this is also not too hard to and this is also easy to understand, which is if I give my x a very tiny range, which could be like 0.01, then I can also make sure that my y value does not exceed the original orange bar.